Good morning, grade 10s, and welcome to this Wednesday, the 13th of May. Luckily, it's a Wednesday and not a Friday. Let's just quickly go through all the questions and comments and things that I've seen popping up here on the side. So, Aaron says his school has started online lessons, so he can't come to all these lessons. I completely understand that, okay? Remember that these lessons, the Lockdown e-school, our entire aim was to try and support you guys as much as possible, okay? Please remember that the lessons will still go onto YouTube, okay? And that I'll still, as far as possible, try and put everything on the drive for you guys, okay? And also remember that I don't mind you taking my videos and my notes and things back to school and asking your teacher for help with them. I really don't mind that, okay? Then Miss P made a very interesting statement saying, ma'am, is it true that online teaching and learning isn't good? Now, Miss P, that's a really, really tough question, okay? I don't think there is a yes or no answer here. I think you guys need to realize that the South African teaching system, as much as we want to say it's very modern, is not that modern, okay? It's very similar to how teaching happened in, like, I don't know, the 70s and the 80s. We still give you the information and you then learn the information and you write a test about it to see how well you understand it or how well you could memorize it. Okay, now online learning brings a slightly different dimension in that sometimes you are required to figure things out for yourself. Okay, and remember, this type of online learning is very similar to what you would have had in a classroom. Okay, you have a teacher and the teacher is here to try and give you information and to try and help you understand what you don't understand. Okay, so you need to just be careful when they say online learning, exactly what type of online learning they mean. Okay, because there are very many types of online learning. All right, guys, so I hope I've had like a conversation about, oh, wait, there was one more question. People saying that they hope that the teachers don't repeat what has been done here. Okay, so remember that not everybody in your classes might have been in a learning situation like this, okay? Which means that there is a possibility that teachers might repeat stuff. Now, I very purposefully focused with you guys on things that are important. Not just for this year, but so that grade 11 and grade 12 is easy. Okay. So don't think that when you do it again in class, it's a bad thing. Remember, I might say something in one way and your teacher says it in a different way. And then you click what your own teacher says a little bit better than what you clicked or how I said it. Or it goes, oh, yeah, okay, now I remember that. Okay, so don't think that repeating this stuff, especially in grade 10, is a bad thing. Okay, anything but, guys. All right. Ma'am, do I know when we are going back? Oh, that is $1 million question. Okay. In terms of different provinces, you'll probably get different pieces of information. And I know because I'm in the Western Cape, even the different districts within the Western Cape are saying different things. Okay. Guys, the only thing that I can say to you in terms of when we're going back, we will know when we know. And that's probably the worst thing I could say to you because we can't plan. Trust me, I'm in the same boat. I like to plan. I'm a bit OCD. I like to know what's going to happen and where we're going and where we've been, okay? But I don't know. I can only go on the hearsay, and that's not fair to you because none of it's concrete. Miss P, the chances of you having to repeat grade 10 is 50-50. However, I've had a lot of conversations with teachers, with curriculum advisors, with subject planners. And the chances are very, very good that you will not have to repeat grade 10. That because you guys are so early in your physical sciences career, that we can logically cut things from your curriculum that you don't need for grade 11 or grade 12. And we can do that in your grade 11 year 2. So that by the time you get to grade 12, when you write your final exam, you haven't lost out on any prior knowledge that you need to get to grade 12. Okay, now lots of you guys are going, oh, we don't want physics. Oh, we don't want chemistry. We don't want physics. Okay, guys, it will always be 50-50. Always. It's not going to happen. Okay, if you choose to do the Cambridge syllabus, which is like the British one, then they split chemistry and physics. Okay, but in South Africa, all the way to grade 12, you do not split them. Okay, right. So they're always going to be 50-50. And the boys tend to prefer the physics and the girls tend to prefer the chemistry. Okay, I'm not always saying it's always like that. It just tends to be like that. Okay, right, guys. So I hope that has like answered a couple of questions. I'm sorry I don't have more concrete answers for you. Okay, I really am sorry I don't. I know as little as you guys know. Miss P, homeschooling's not bad because this program's always going to be there. And so you can use programs like this and then write your tests and exams and things online. Okay. When I lived in Gauteng for a number of years, I was a homeschool tutor. So that's what I did. Right now I'm working at a government school. It's same, it's not very different. Okay. I don't think the one is better than the other one. It's all about how you approach it. All right, guys. So yesterday I gave it you a circuit. I need to zoom up. No. I need to zoom the circuit. And this is when I said I gave you homework, what I meant by I gave you homework. There we go. All right. If you didn't do it, don't panic. Those of you who've ever had class with me knows that my heart is really, really tiny. I don't easily put people on detentions for not doing homework. I just feel sad for you. Anyway, are we ready? First question is we need to calculate the, come on, pen, the parallel bit there. Okay? Right. Now remember yesterday I said to you guys the only thing that is different between this parallel bit and all the other parallel bits we've done is that there's 3. And I hope that my little extra explanation yesterday, oh, that's way too high. I'm going to go all the way over my diagram. I hope the extra explanation yesterday of where I get that -1 at the end of my formula helps a little. All right. Now, normally when we were doing this and we had 2 branches, we'd stop there. But now we have 3 branches. Guys, remember with physics, even though you kind of look at it and go, meh, I don't need to write the formula. Write the freaking formula. Why do you write the freaking formula? Come on, pop quiz. Why do you write the formula? It's the same reason you show the substitutions. Come on, take a guess. Why do we write the formula? Why do we show every single substitution? Erin first, fastest finger first. Tyrese, yes, it's so that you don't make mistakes. But ultimately, guys, you get marks. Okay, you get a mark for the formula, you get a mark for the substitution, and you get a mark for the answer. Okay, you need to just get yourself into that habit. Remember what you get marks for, and just get the marks. Okay, and that's why I try and teach you guys to do this in like a system, because I've marked matric papers for long enough. Oi, didn't think about that one. I've marked matric papers for long enough to know exactly what you get marks for. Asiri, that is a very good answer. Okay, Asiri says, I hope I pronounced your name correctly, that by writing down the formula and showing the substitutions, you're showing the marker exactly what you are doing. You are showing the marker your thinking. Okay, now that's something that's very hard for people to do whose brains click it quickly. My high school roommate was like that. She got like 98% for physical sciences. Yes, I know, crazy. But she had to force herself to write stuff down because a calculation like that she could do faster. Yes, Miss P, I know, I didn't get those marks. She could do a calculation like this faster than she could write it down. So she had to force herself to write everything down. Miss P, she got like 98 for physical sciences. She got 100% for mathematics. She did AP math. She did IT. She did EGD, which is like the technical drawings. Okay. She is just flipping genius. All right. But she had to teach herself to answer papers in the way that she was going to get the marks for. Okay. So it's also a different struggle. Come on, you do EGD. It's really cool. I would have loved to be able to do EGD, but I did mathematics, physical sciences, life sciences, which back in the day was biology, and then I did music as a subject. I was weird, but that's okay. Okay, right. So we have that parallel one. Cool. Now, let me just move that over there. Next question, calculate total. Okay. So, remember yesterday I said to you guys, you might every now and again have to redraw stuff. So, if we now think here, these 3 here, we said their equivalent resistance is 1 ohm. So, if I redraw that little bit of the circuit, then I have the 1 ohm resistor, which is the equivalent resistor of the parallel bit. And then I have a 5 ohm resistor. Nah? And this is going to be R1, 2, 3, 4. Thanks, Ash. It's fine. At least I could laugh at myself, hey? Okay, so that's now what we end up with. Okay, does that make sense to everybody? Okay, so now, oh, guys, just a heads up, but I think we might miss it. Normally, when I have you guys on a Wednesday in the afternoon, our bins have already been removed. Now, I think we might miss it today. But If the dogs go absolutely mad, then you know that the guys for the bins are here. And then, I don't know, we're just going to have to deal. Okay, I apologize. Miss P, I just realized that yesterday you forgot about your -1. Did you remember about it today, or did it just work out correctly just because? Just check for me, Miss P. Oh, there's a geo student. Ah, good job, Miss P. Good job. You see, that's why you are allowed to make mistakes. Because if you don't make mistakes, you don't learn. Okay. I'm not quite sure who said it. I'll ask the husband when he hasn't got his earphones on. I think it's one of the martial art guys that said the master has made more mistakes than the novice has even tried. I can't remember who said that. Okay, the husband says he also doesn't know. But guys, Confucius maybe. Oh, we think it might be Confucius. Okay, so guys, if you don't make mistakes, you are not learning. We have history and consumers and bio. Yo, guys, we're like such a cool mengelmoes and EGD. I like it. I like it. You guys, can you see how, oh, Poppy has got business. Sure, that's out of left wing. That's so cool. See, guys, like we're this humongous mengelmoes of people. Erin, that's a good question. Let's have a look at it. Okay. Erin, I just want... Ooh. Erin, don't panic. Guys, don't shout at me. I'm sharing my entire screen with you. I know. Don't panic. Don't panic. Is it sharing? Yes. Okay, hang on. Erin, I just quickly want to find, it might take me a little while. Is that my downloads? No, that's not my downloads. Oh, this thing's in the way. Yes, I know. I have 20 million things on here. I am trying to find. Oh, here we go. Exam guidelines. And now you guys have disappeared too. And I need to pull you guys back over here. Oh my goodness. Okay, I'll pull you back over now. Just give me a second. Let's try a new share. Did I actually open the document? Not yet. Okay. I'm going to quickly throw you back over to the whiteboard while I get that document open. Where's the participant? Okay. Sorry, guys. Boom. It's open. It's open. Just on the wrong screen. Sure. Guys, I currently am running 2 screens, and this is like really new to me. Like really, really, really new. Oh, I see Kahoot. Are you guys wink, wink, nudge, nudging that you want to play Kahoot? Is that where this is going? Okay, wait. New share. There we go. Okay, don't panic. I'll tell you what Kahoot is. Let me just, who was it? Tino. I completely lost who asked. Dum. Okay, no, it was Erin. Erin asked me, ma'am, why does the series 1 not have a neg 1, but the parallel has? Okay, so, well, don't panic. Don't panic. When you write physical sciences, here we go. This is what I was looking for. When you write physical sciences, you guys all see my exam guidelines. I haven't shared something wrong here. You guys all see it. I don't hear any no's. Okay, Ash, Zalnay, guys said. So you are with every test and every exam, now please listen very closely, supposed to get a information sheet like this. Okay? Grade 9, you are not supposed to. I disagree with my grade 9s. I do give them the same formulas that you get here. So grade 10, grade 11, grade 12, you are supposed to get information pages. They look different for grade 10, different for grade 11, and different for grade 12. Okay? Which is why I recommend you go get these exam guidelines. They are in the drive. I will add the grade 11 and 12 one to your drive if you want to. Okay? So that you can always see what you get. All right. So you get various symbols with their values. Like remember when we did static electricity, okay? There's the charge of an electron. You don't have to remember that, okay? And if they ever, for some other random reason, ask you the mass of an electron, there it is too, okay? Now, this you guys will get to, formulas of motion. This is too much fun. Like, I actually feel like this is the next thing we should do. Like, I think we should just have fun with this. Okay. There's the waves equations that you get. And here is the electricity equations that you get. Okay. Now, I know the one, if you look here, can you see that R equals V over I isn't here? Now, the reason for that, I could go back down, just give me a second, is this is 2015. Okay. Miss P, yes, this is called the exam guideline, and they tell you everything you need to know. I'll go back up so you can see what it looks like. Okay. So this is the formulas you get. All right. Tino, it's okay. Waves is only really in grade 10. Like after that, you see it for photoelectric effect in grade 12, and that's it. Okay. Now, Erin, look here at the series. Series, you are only asked to add and add and add resistance. Okay? That is all you have to do for series. But here is the parallel one. Oh, come on, you're very lucky they give you exam guidelines in school. I try and give my learners a 2. And like I say, guys, if there are any of you that need it, just let me know. Okay. So, Erin, you see this parallel thing here. You see how it's got the 1 over. Now, this is the formula you get. Okay. But I know from experience, and I've seen this in grade 12 papers. So my grade 10s, if you think you are the only people that make this mistake, you are wrong. I see it in grade 12 papers where they forget that it is 1 over P, 1 over R parallel. Okay. And so they do this conversation here, the whole calculation, and then they forget to flip it back around. Okay. So, Erin, my suggestion to get out of this problem, and now I'm going to pop you back to my new whiteboard. Dunk, dunk. Right. So, Erin, do you see here I don't write 1 over R parallel? And because I don't write 1 over R parallel, I have to fix it by that minus 1 over there. Does that make sense? Guys, some of you might already get it, and some of you might have half heard it, but your brain isn't worried about it yet. I do not mind saying it 1,000,000 times. I do not. Okay? That's why I said to you guys, we can carry on with new work, but I really want you guys to be as comfortable as possible with circuits, okay? And some of the stuff, like the stuff, the combined circuits we're doing now, is a little bit above what I think you might have to do for grade 10, but it's not what you're going to have to do for grade 11 or grade 12, And so I'd much rather, no. You are allowed to write it like that. I cannot remember why. There's a reason for it that they give in the grade 12 marking. I remember very specifically, we had a big discussion about it in the grade 12 exam last year. I marked this question end of last year. Okay, so they cannot, like I say, Brayden, I know, we've done 2 questions, not 1. Okay, you can write both, Larissa. I think that's a good idea. Okay, right. So we have parallel and we have total. Now we need total current. We have total volts. We have total resistance. Bring my pen back over here. Now, this is number 3, C3. I'm going to give you guys the triangle because I know you like my triangle. V-I-R. I want I. So it's going to be V over R. I gave you guys 12 volts and we worked out 6. Sure. I don't even need a calculator for that, Oak. All right. Easy peasy lemon squeezy. Right. So what I tend to do is I now tend to write this thing here back into my diagram. Okay. So here I'm going to write 2 ampere. Now we've got to work out that V and that V. Everybody still okay with me? So for V1, again, guys, like I said to you, split the diagram. Know what you are working with. I know that 2 ampere flows through this 5 ohm, and I can again use this formula. So I can say V equals I times R. I've officially run out of board. That is so sad. Board going down. Anyway, so it is 2 ampere times 5 ohms, which is a very easy 10 volts. Accounting and business studies. Leora, let me do some research for you today, and then when you pop back tomorrow, I can give you a couple of links. I know they've got accounting for the grade 12s, but I know we don't have accounting for everyone else. Okay, guys, that one was pretty easy. Easy peasy lemon squeezy. Man's got our covers. Our answers stay breezy and my rhymes are cheesy. Dude, you haven't heard my chemistry jokes. Wait until you hear my chemistry jokes. Sure. Yeah, I know. Okay, so now we've got to have V2. Okay, we know V1. Move. There we go. Okay, we know it's number 5. V1 plus V2 must give me the potential difference. Okay, we've got 10 plus V2 must give me 12. And so V2 equals 2 volts. All right. That was the hardest parts. No, I lie. Those are the easy ones. Now we've got to find Hong Kong color, that one. We got to find that current there. Okay. So we have 2 volts and 3 ohm. Tyrese, no, yes, what? So I have my 3 ohm. I know that the voltmeter reading over it is 2 volts. Oh, okay, fair enough. And I want to know what is the current. Can you see, guys, how I pick apart my big diagram, and for each question, I just draw what I need? Okay. Tando, you're like super late, dude. It's okay. We've been having like quite an interesting day. Okay. So here's our triangle. We want I. So I is 2 over 3. Nah. Oh, you guys must shout at me. I didn't write down the formula. Is V over R, which is equal to 2 over 3. And remember, oh, thanks, Brayden. Good, Tyrese, good. I want the answer in a decimal, correct? Two decimal places. So it's 66666. So I make it 6, 7. It's current. So it needs to be in ampere. Now, guys, a lot of you will see that the mistakes you made yesterday, you were able to correct today. And that's all you can do. That is what you need to do every single day. Well done. Okay? That is how you get better. Okay. So now yesterday, I threw this very confusing one your way, and you all like started getting very upset at me. Okay. This one. Right? And I said to you that the reason why it is frustrating is because the previous ones we did, I'm so happy that the homework makes you happy. That like absolutely works for me. Okay, so the reason why this example we looked at yesterday made you guys think differently is because it follows a different format as the examples we've done up to now. Okay? This was me explaining the R minus 1 the whole time yesterday. Okay, so in the examples we did yesterday and the homework I gave you guys, we had one resistor in each of the branches of the parallel bit. Okay? And then we had a parallel bit that we put in series to something else. What I'm doing now is I'm flipping that over. I am saying to you, now in one of the branches, we have 2 resistors in series, and they are in parallel to another resistor. Okay. So, in the past, where we calculated the parallel, the entire parallel component first, and then added it, now we've got to isolate this branch first. So now we've got to say, I've got to calculate the resistance of this branch first, and then use this resistance and that resistance to get the parallel resistance. Okay, So that is the order we're going to do it in. We sort out this one branch first, and then we calculate the entire parallel thing. Okay. So that top one is super duper easy. Okay. Larissa, why does it change? Because of the idea of volts. Okay. Let's just slow down and let's think about what happens to electrons. Okay. So each electron that leaves this battery here has 4,5 volts of energy. So the electron gets here and it can either go up or it can go down. Whichever way it goes, that electron has 4,5 volts of energy. Let's look at an electron that goes down. An electron that goes down will give all 4,5 volts of energy to this resistor. It's only going through this resistor and there's nothing else in the circuit. Can you see that? So the only place that this electron can spend its energy is on this 5 ohm resistor here. Okay, so if I now add a voltmeter randomly, okay, then we will find that the voltmeter reading over this 5 ohm resistor will be 4,5 volts. Okay. But if we look at an electron that goes up, now we've got to keep our wits about us. This electron goes up. It has the 2 ohm resistor as well as the 1 ohm resistor that it needs to share energy with. So this electron cannot give all 4,5 volts of energy to this 2 ohm resistor. It will give some to the 2 ohm and whatever's left to the 1 ohm. So that means that if I put a voltmeter, oh, now you guys are going to shout at me again for not being able to draw. Okay, if I put my voltmeter over both of them, then I'm going to get 4,5 volts. But if I put my voltmeter over here, that one is not going to be 4,5 volts. Okay, because they have 4,5 volts for both of them. Okay, and that is why, because I have to give my 4,5 volts between these two resistors, that I have to add them first and then calculate the parallel component. Okay, does that make more sense? Now guys, again, this concept is, I'm not saying it's completely outside of grade 10, but it is pushing the boundary of grade 10. Okay, but I would definitely not be doing my job if I didn't give you guys examples like this. Okay, let me clean up my diagram just a little. Right. Okay, so we're going to calculate this resistance first, super easy, and then we're going to calculate the parallel one. Okay, so the top branch is very easy. Remember guys, this is the formula on your information page. So it's 2 plus 1, so it's 3. Like nothing to it. Now, what I'm saying is, if I redraw that and I have one resistor in the top branch and one resistor in the bottom branch, that is now what we go. If I redraw this whole thing here, I get that. Okay. Come color. Ha. That one. Okay. Here we go. Right. That's how I get that 3 ohm there. Erin, you are absolutely correct. That the parallel branch, the whole parallel thing, I can think of as one big resistor, which is why normally when we start the other way around, I kind of replace them. That's also, they refer to it as the equivalent resistance of the parallel bit. It's a good question, Erin. Okay, so now that I know this about the parallel thing, now I can calculate the resistance of the whole parallel branch. So I get 1/3 plus 1/5, make 1. Come on, I think you are right. Divide by 3 plus 1/5. I just have a sharp calculator, so the amount of brackets. Good job. I get 875, but okay. So guys, do you see how the process is different because what we have to deal with is different? Okay. From here, there's so many things that you can calculate. Okay. From here, the process is going to be the same as anything we did for this humongous circuit here. Okay. So, right. Dum, dum, dum. Line. Homework time. You see how, guys, I'm cheating my straight lines. Ha ha ha. There's a little function there. Check there. It says straight lines. Dun, 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 dun. Now I want to put a circle in there. Dum, dum. Now we're going to change it to, ooh, wait, we can finish that one there. Dunk. All right, now we're going to change it from a straight line to a box. Okay, so Brendan, I want us to do one more example like this one. I'm going to give you guys slightly more to calculate than I calculated. I want to see if you can stretch yourselves just a little. Go. And then we check. Oh, I don't want that. We check tomorrow, okay, whether everybody is comfortable with these combined circuits. Okay? And if everybody says to me, ma'am, these combined circuits are cool, we understand what's going on, then what's tomorrow? Thursday. Then we can decide. So from there we have options. Oh, now I go to bad lines again. Let's try it a better way. Okay, so the options that we can try is we can try to do a Kahoot. Okay, I can do a Kahoot with you guys. I did one with the grade 10 maths lit and we had too much fun. Okay. Or you guys can say to me, ma'am, we're big. We don't want to have fun. And we can go straight into a new topic. So that is something you guys need to think about during the course of today. And get back to me. We're all going Kahoot. Yeah, okay. Okay, guys. Ooh. Are you guys voting Kahoot? Okay, I'll start with it. I'll start with it. Not for tomorrow, for Friday. Go. So, I want you, first of all, to calculate. Kodlimidi, I will explain Kahoot to you guys nicely tomorrow, I promise. Okay, so first one I want you to do is I want you to calculate this branch for me. Then the second one I want you to do is to calculate the whole parallel for me. Okay. The third thing I want you to calculate is the total current. Okay. Then C for bonus marks, if you can calculate the current through this bottom one. We got that? And then for those of you who want like a serious challenge, see if you can calculate that. So 1, 2, and 3 is compulsory. 1, 2, 3 is must. 4, 2 is the parallel component. Okay, so 4 is the current through the bottom branch. Okay. Better? And 4 is a challenge. And 5 is that V in the top. And it's a Uber challenge. All right, guys. So that is it for today. I will see you guys tomorrow. Tomorrow we'll see if we can answer this, and then we can Kahoot on Friday. For those of you who don't know how it works, don't panic. Don't panic. I have a Kahoot set up. All right, guys. Have a fantastic day. I hope you stay nice and warm and safe. And I will see you tomorrow. Bye.